Differential equations are essential for modeling changes in fields like science, engineering, and also mathematics, such as population growth, motion, and also heat transfer. Since many are too complex to solve exactly, numerical methods like the Euler method are used to find approximate solutions. The Euler method, a simple and accessible approach, solves differential equations step by step by breaking problems into smaller increments. In this presentation, we apply the Euler method to solve a differential equation using Microsoft Excel. Excel provides a straightforward platform for calculations and also visualizations, allowing for clear step-by-step demonstration and also result analysis.
Excel is a feature-rich application built for Microsoft Office, widely used for various data-related tasks due to its easy-to-use interface and extensive features. It's applicable for everything from financial analysis to scientific research. One of Excel's standout features is its ability to solve differential equations using built-in function and customization options. With VBA, user can automate and perform higher-order computation. Excel accepts improved numerical method to solve differential equations, which describe relation between a function and its derivative. Methods like Euler or Ramscotta can be applied using cell iteration. The dynamic layout allows users to set initial conditions, step size, and formula directly in the spreadsheet. Any changes update calculation immediately, making it easy to test different scenarios interactively. Excel visualization capabilities are another strength. It provides tools with various chart types such as line chart and scatter plot to illustrate how functions change over time and test numerical results against analytical solutions.
Next, Excel is a versatile tool for solving differential equations using numerical method like Euler's method. It allows users to set up initial conditions, organize data in columns, and apply formula for iterative calculation. By incrementing values of the independent variable and using recurrence relation, Excel can approximate the solution to the equation at each step. Its drag and fill feature simplify iterating through calculation, and bullet graphing tools make it easy to visualize the result. Though ideal for small-scale problems, Excel is great for quickly experimenting with different step size, initial condition, and function, making it accessible for those looking to gain insight into differential equation without needing advanced programming skills. Euler's method is a basic numerical technique used to approximate the solution of ordinary differential equation with initial condition. It works by discretizing the equation into small steps along the independent variable x, using the derivative fxy to estimate the change in the dependent variable y at each step. To calculate the value of y at each subsequent point, while simplifying the computative efficiently, Euler's method is only first-order accurate, meaning that its error can accumulate with larger step size, making it less precise for more complex of stiff differential equation.
Next, I will explain differential equation problem using numerical solution of Euler method using Excel. The equation we are solving is y equals x squared. In this problem, we use a step size of h equals 0.1. This value determines the interval between x and values. We define h at the top of our Excel sheet for reference. In column n, we have the step numbers starting from 0. In Excel, we type equals sign and then click on the cell above with the initial value of n, then plus 1 into the cell and enter. Once the formula is entered, we drag it down the column to calculate the step numbers for all subsequent rows. Next, in column Xn, we input the initial value at 0 equals 1. So in this cell, we type equals, then select the cell above, then type plus sign and select the cell containing incrementing the h equals 0.1. Then in column yn, we input the initial value y0 equals 1, the previous value of y plus h times the slope function. The x in the previous step times the y in the previous step, then we use Ctrl D as before. We select the cell with the x and y value. Next, we select the insert menu and expand the option. The x-axis will represent xn, the y-axis will represent yn. This graph shows the quadratic relationship y equals x squared. We can see how the values of yn grows as xn increases. Next, I will explain differential equation problem using numerical solution of Euler method using Excel. The equation we are solving is y equals x squared. In this problem, we use a step size of h equals 0.1. This value determines the interval between x and values. We define h at the top of our Excel sheet for reference. In column n, we have the step numbers starting from 0. In Excel, we type equals sign and then click on the cell above with the initial value of n, then plus 1 into the cell and enter. Once the formula is entered, we drag it down the column to calculate the step numbers for all subsequent rows. Next, in column xn, we input the initial value at 0 equals 1. So in this cell, we type equals, then select the cell above, then type plus sign and select the cell containing incrementing the h equals 0.1. Then in column yn, we input the initial value y0 equals 1, the previous value of y plus h times the slope function, the x in the previous step times the y in the previous step. Then we use Ctrl D.
Okay, so next we are going to use Desmos. First, select the x and y values in Excel from x equals to 1 to x equals to 3. Ctrl C to copy, Ctrl V to paste in Desmos. Then our data will show as a table and the graph are plotted as dots. We can also select the color of our points, so we choose purple for the approximation using h equal to 0.1. Okay, next we are going to use h equals to 0.05. Okay, select the x and y value for h equals to 0.05, which is from x equals to 1 until x equals to 3 in Excel. Ctrl C to copy and Ctrl V to paste in Desmos. And the data will show as a table, then we change the color to orange for h equals to 0.05. Okay, so now we will insert equation y equals to x squared for the exact solutions. And the interval will be x is between 1 and 3. And we will also choose black color for the graph. You can also zoom in or zoom out the graph to see the approximation or the points that you want. Okay, based on the video before, Desmos is used to visually demonstrate and understand Euler's method, which is a numerical approach to solving differential equations. So why we use Desmos is because it can help us to plot the actual solution and the approximate solution obtained using Euler's method side by side. This will make it easier to compare and see how closely the numerical approximation follows the exact solution. As you can see, if we zoom in on the graph, we will see the approximate solution. So if we have smaller step size, h of 0.05, it will give better accuracy that is closer to the exact solution, compared to larger step size of 0.1 that deviate more from the exact solution.
Conclusion is, the solution provided a detailed analysis and implementation of the numerical method to address the problem effectively, while the results demonstrate that the method achieved a high level of accuracy, meeting the desired thresholds for precision with the acceptable computational time. From the graph, we can see that the graph illustrates a clear upward trend, with yn increasing steadily as x progresses from approximately 0 to 3. This indicates a non-linear relationship, possibly exponential or polynomial in nature. The smooth curve and consistent pattern suggests that the numerical method employed to compute yn is both stable and accurate for this range. In summary, the numerical method proved both reliable and efficient, making it a strong candidate for similar problems in future applications. Thank you.